Alright, 3 forms of quadratic equations. What's one of these forms? Give me one of the forms, thanks. Zay, give me one of these forms. Vertex is? Y equals?
Is, I forget the letters.
Probably shouldn't have picked that one then, hey? George, help him?
I'll do general form.
No? Okay, you can do general, yeah.
Y equals mx plus c.
Great general form of a line though. James?
Vertex equals A brackets.
Which one are you doing?
Vertex.
Vertex. A brackets.
X take K or plus B. K bracket plus K. Squared.
Very good. Otherwise we'd have another linear function, but the squared saves you. Yes, George.
General form is ax squared plus bx plus c.
And intercept form is Jacinta?
That was the only one I didn't do.
It's unfortunate. Phoebe? Nick?
Did not bracket x1 minus x2 bracket x whatever.
That's what you meant. Yeah, that's good. He's right. Had the key. Had the polynomial is just not quite in the right order. Not the polynomials, the pronumerals. There are 3 forms. Why do we use these forms? Why do we? Can they all be the same? Can we turn our turning point form into a general form? Can we turn our intercept form into that form? We can do all of those things, but we have these 3 different forms because sometimes it's a lot easier given the information that we have. When would it be better to use intercept form?
When you have the intercept.
When would you use turning point form?
When you know where the vertex.
Turning point is when you use general form? When you know nothing and you're hoping for the best. Okay. Maybe you know where when x is 0, you might know your c value, so that takes out one of your variables straight away. Cool. So all the way through this, what are we trying to remove? If I'm trying to determine an equation, what should my final form of the equation have? Y equals, so the y remains. Where I've got a, b, c, what should be replaced? Numbers, correct? What should be left? What's the only other variable I should see? X. Cool? So all my pronumerals should be numbers except for x, which should remain. What's the problem if I gave you how many points would I need to determine a quadratic? How many known points? 3. Why do I need 3 points? This might bring me to my next part of the board. So have a look at that. Why do we use simultaneous equations? So when we introduced simultaneous equations in year 10, yes, we did them in year 10. How do they often look? Is this a simultaneous equation? Is that a simultaneous equation? Who says yes? Who says no? And why do you say no? Only one of them. I've set you up. I've made that look like a simultaneous equation, but I've only given you one. So whenever we're using simultaneous equations, we have multiple equations. That's one thing. What else do we have? Is this a simultaneous equation? I should have done this with that number, but anyway, I'll go. Is that a simultaneous equation? There's 2 equations, but why is it not simultaneous?
You need one to have a y value as well.
So it doesn't have to be a y, it could be a p or a q or whatever, but I need 2 variables, correct? At least 2 variables and at least 2 equations. That's the heart. So simultaneous equations, the reason we use those is because we have multiple unknowns that we need to solve. I want you to write that down. We use simultaneous equations because we have multiple unknowns or variables. So how can we see how this might relate to each other? Yep, Ethan.
Use two different forms.
I can use two different forms. I could give you, for example, a graph. Let's do an imaginary graph here. So here's my graph. Now what I'm going to do is I'm going to create a quadratic on that graph. You can create your own, but I'm going to create one that has a turning point here and goes through this point here. That's a really good graph, isn't it? Okay, so I only know 2 points on this graph, so when Ethan said 3, he sort of lied, but he sort of didn't. 2, -1, 0, 1. Sort of did, sort of did. What form of function should I use? What type of equation have I got there first of all? What does that look like? It must be it's a quadratic. We can tell it's got that quadratic shape. So I've determined I need to use a quadratic. I need to use one of these three. Which one should I use? Vertex form. So I'm just going to write my general form out. Y equals a x minus h squared plus k. Correct? I've actually done a really bad example because I don't even need simultaneous equations, but that's okay. Do I know anything about this function straight away? Just by looking. What do I know? I know that h equals 2 and k equals
1.
Negative 1.
So what don't I know?
A.
I need to determine a, correct? So I've got y equals a x minus 2 squared minus 1. And I need to determine a. How do I determine a?
Rearrange the equation.
Before I do that.
Expand the reference.
I could, but before I do that, I'm not going to. Do we know anything else about this function? Anything? I can start at a given point. What point should I start in?
0, 1.
So let what? Let x equal and y equal? How many unknowns do I have now? 1. So I want you to solve for that one. Okay. So that's one that doesn't require simultaneous equations. I'll give you a bit of a break and a chance to do a couple of those, and then we'll come back to the simultaneous equation stuff.